So yesterday we have seen the what is malloc and how to allocate the memory using malloc and what is the difference between malloc and calloc. One more important thing that is the write down with me. If we lose the base address of dynamic allocated memory, we lose the base address dynamic allocated memory. That memory becomes leak. So how? Just a second. Suppose I do in my program, this is my main function. In the main function, I have did like this way. I taken one pointer integer star p, and in the code of line, I have did p is equal to malloc of 10. Then 10 by data allocated, and that starting address store in my pointer. After some lines, I do again p is equal to malloc of 20. So here my p is at 2000 address suppose, and I am creating the malloc of 10. This is suppose the 1000 location, and this is the 3000 location. Here I am allocating the memory of 10 and starting address store in my pointer. After sum of line, what I did the p is equal to malloc. So same pointer storing the address. So instead of 1000, it will now storing the 3000. Now we have no any backup of this address or nothing else. So this data is already created in heap section of my RAM. But that starting address no one knows because this pointer has disturbed. So if we lose the base address of dynamic allocated memory, that memory become leak. So this memory become leak. So what is the solution of this? So solution I will write down. So first draw this how the memory will become leak. So here two solutions. First solution is if we decided we don't want to use this memory anymore, so we will use the free function. If we decided we will not use this memory, then use free function. So free will delete all the memory that is created in the heap section of the RAM. And second solution is want to use all memory, then catch with different pointers. Understood this? So we have to use second pointer, and I will use here instead of p, I will use suppose here different pointers star q. So here I can use q, and that is perfectly okay. So these are the two solutions. So write down this. I will be back in 2 minutes. Okay, done this.
Yes.
So solution understood. If we decided we will not use this memory, use free function. If you want to use all memory, then catch with the different pointers. So one more thing that is asked in the interview, that is the important, that is the dangling pointer. What is dangling pointer? Where the pointer is pointing to unreserved memory is called dangling pointer. So unreserved memory, that is memory is not available in my RAM. So when this type of situation will create in a dynamic memory allocation, after freeing the memory, that pointer still holds the base address of that memory. So then this pointer is called dangling pointer. How this happened? So yeah, we will see using code. So in diagram I can do like this way. Suppose I do the integer star p and p is equal to malloc of 10. Then I have the free memory free p. So my memory is whatever the allocated that is now free. And you can print here starting address of p and here after that p. So p holds at the starting address of this memory location still. So this pointer become now dangling pointer. So after freeing that memory pointer still hold the of base address of that memory. So this is called dangling pointer. We will see using the program. Done this
Yes.
code has include standard library.h, integer star p, P is equal to malloc of 10. Then printf 1 P is equal to percentage U slash N dash P memory. Then again I am printing the address. So you can see my address is same. Understood this? So now this memory is become leak. Pointer is not leak memory. This is called the dangling pointer. Pointer is still holding the unreserved memory. So now free memory, then after also pointer is pointing to unreserved memory. Write down this program. Then we will see the solution of this. Then what is the solution of this? How to avoid this? So solution of the dangling pointer. Make the pointer as a null pointer immediately after freeing the memory. Make the pointer as a null pointer immediately after freeing the memory. Understood this? So whenever you completed your task after freeing the memory, make pointer as a null pointer. So this is the solution. So whenever the in interview the interviewer will ask why we use the null pointer. So this is the important question you ask me, why we use null pointer. What is the need of null pointer? So now this cleared, right? To avoid dangling pointer, we are using the null pointer. What is dangling pointer? Pointer is pointing to the unreserved memory. That memory is not available in my RAM, and I am trying to access that. So that is called dangling pointer. And how to avoid dangling pointer? So using the freeing function. So after immediately clear that memory area. And what is the solution of that dangling pointer? So make the pointer as a null pointer immediately after freeing the memory. So yeah, you have to tell that how to avoid the dangling pointer. So you have to, once your task will complete, you have to make your pointer as a null pointer. So this is example in the dynamic memory allocation. So it's general use case when your pointer is pointing to unreserved memory. This is called dangling pointer. So in the case of static, dynamic, or anything else, pointer is pointing to that memory is not allocated in the my RAM. So that is called dangling. And how to avoid that? We will make the pointer at null pointer. So why we use null pointer? To avoid dangling pointer. Dangling pointer where the pointer is pointing to unreserved memory. Okay, so this is the two important question for interview. Next, what is the life of a dynamic memory allocation? So life of a dynamic memory allocation start when we call malloc or calloc to allocate memory, and life ends when we free it or program execution gets completed. So life will start when we create this malloc and or the calloc, and life ends when we use this free. If we will not use free, then when my program execution gets completed. Life of dynamic memory allocation. Dynamic memory starts when we call malloc or calloc to allocate a memory. Life ends when we free it or program execution gets completed. So this is the life. What is the scope? So scope is similar like local and global. Suppose, for example, I have integer star abc function, and this is my main function. I am taking the pointer. P is equal to abc function call. I am doing this, and here this is my abc function. So it is returning the malloc of size of integer. So scope is decided when you use declare a pointer. If you declare global, in all function can access that. Otherwise, whatever the function is called, that only the access that. What is the life of dynamic memory starts when we call malloc or calloc to allocate a memory. Life ends when we you pre it or program execution gets completed. So it lives is till the my program execution gets completed. But when I can use this, so if it is globally, then I can use in all the functions of my file. If it is locally, then I can use which function I've called, and that function only I can use. So scope decide when you declare pointer globally, scope in all function can access that. Otherwise, local function only access that. Okay, understood this?
Yes.
Done this part?
Right. Great. Great.
One more question in your mind that when I use the free function, so how free function knows that how much byte of data I need to clear, right? So the question is the how the free function knows that how much byte, how much memory it has to free or it has to unreserved. So when malloc allocates the block, it allocates extra bytes to whole an integer containing the size of the block. So whenever the malloc is creating the memory, at that time not only directly creating my memory, so this is my memory suppose. So here it's creating the two blocks in my RAM. First block is for the length of block, and another one is the memory for memory used for caller. So we have called this memory, so they can use this memory and this starting address they will give. But here also they make one block, that is the length. So whenever we use the pre function, the starting address it goes, so it will identify the what is the length of my memory, and then after it will delete it. So here written starting address by malloc. Understood this?
Yes.
So when malloc locates the block, it allocates extra bytes to hold an integer containing the size of the block. Okay, done this.
Yes.
Mhm. So now we have started this. At time we have seen this is the four function available: calloc, malloc, free, realloc. So you know now what is malloc and how to use. You know now how what is calloc and how to use the calloc. So malloc and calloc both are similar way. Free also you know now. Now we will use the what is the realloc. Realloc is useful for increasing or decreasing previously allocated memory. So reallocation. The next we can see is realloc. So realloc, that means reallocating the memory. So increasing or decreasing previously allocated memory. So for example, in my program I have did p is equal to malloc of 10. So this is my data is written. After certain situation, the I want to increase my memory. So what I will do? I will do p is equal to realloc, and I will provide here the my starting location of the p and How many bytes I need to increase? So I need to increase 50 bytes. Here, reallocation will give you new address. Here it is not same address. So address you will get the new, and it will reallocate the more bytes and it will send the new address. Okay. Suppose you want to decrease the memory. Suppose I have allocated the memory is p is equal to malloc of 100. This is my data, and I want to decrease my memory. Then I will do p is equal to realloc, then starting location of p, then 50. Suppose that is 100, so 102 I want only 50, so 50 decreased. So here this is called decreasing, and this is called increasing. So how it is working like this? So when we create the malloc of 10 bytes, so that is the 1000 location suppose, and my pointer is 2000 location, and pointer is storing the 1000 location. When we create the 10 bytes, so 10 byte will created in my memory. With 10 byte, there is one more size block is also there. As we see, this is the malloc allocate subblock. It allocates extra bytes, hold an integer containing size of the block. So here size block also is available inside that. When we call p is equal to reallocate p and 50, so what reallocate will do here? Reallocate will check the starting address, this is the 1000, and how much byte I need to do. So starting address reallocate got, so reallocate check this size. If that size is 10, then it will increase more 50 bytes, not this location but new location. It will take this 50 bytes, and it will give the starting location of these bytes, that is suppose 3000. So now my pointer will point to 3000. So whatever you have data stored, that will copy here, and this memory will become free, and here your new starting location you will get, and this is my, like this way my memory is allocating. Again you have to decrease the memory, similar way reallocate will do this. So your 100 byte data to convert into the 50 byte, rest of the 50 byte will remove. So total 100 byte will remove, and only first 50 byte will copy that, and it will create new memory, and then new starting address you will get. So like this way we can increasing or decreasing the memory using the realloc. So this realloc also you have to try by yourself, and you have to check how the realloc is working, and if you have any question you can ask me later. Next most important question for the interview: without using free function you have to make malloc free. Without using free function I have to delete my memory. How we can do? So this is my p is equal to malloc of 10 or 100 is created. How I can free this memory without using free function? If I will use free p, then my memory will get free. Without using free function you can do like this way. You don't want any here starting location or anything, so you can do this realloc direct call. Then here you can pass the starting address of your pointer, and size is 0. So here I don't want new memory reallocating size, so I want size is 0, so that means no new memory, and what are the previous data that I need to free this. So without using free function you can use the realloc function, and you can free your memory. Understood this?
Yes.
Mhm. So in homework you have to do try by yourself. Okay, next concept is the very much important concept. So tomorrow I will start, but yeah, I will give the basic of today only. So give heading in your book function pointer. So this is the most important concept. So function pointer, what is function pointer? A pointer which can point to function is called function pointer. Pointer which can point to function is called function pointer. So syntax, so this syntax is for the, I can write here, for function pointer declaration. So what is the syntax? Syntax is like this: return type, star variable name, in the bracket argument 1, argument 2. Here argument will be my function name, or without function name also we can use. So we will see this. So this is my arguments. So what is function pointer? A pointer which can point to function is called function pointer. So this is my pointer. Will be point to function is called my function pointer. So we will see, for example, integer. I will take one pointer star p, and what are the arguments? How many arguments I have to pass? So here my p is a function pointer which can point to a function. So p is a pointer which can point to a function. That function should take two integer arguments. So two integer arguments and should return integer. So p is a function pointer which point to a function. That function should take two integer arguments and should return integers. Understood this? So we will see with example, then you will understand much better way. So this is the syntax. So what is the meaning of this syntax is p is my function pointer which point to a function. That function will take two arguments, integer arguments, and it will return also something in the form of integer. Yeah, we will see with example tomorrow, because that is the little bit big concept. Yeah, we will see tomorrow.
Okay.
Yeah, I will complete tomorrow function pointer. Then, uh, yeah, I will arrange one more class on the Saturday also. Let's see Saturday what we will do. User defined data type structure, union, enum, type def. Like this, we will one by one we will start. Okay, so keep do practice and keep do revision also. Whatever we have learned till now, each and every concept have linked to each other. So do revision also in the regular basis. Okay, see you tomorrow. Bye.
Yeah, bye. Thank you.